Okay, you know the feeling. It's one of those scorching hot summer days. You climb into your car, which is basically a mobile oven at this point, you turn it on, and that blast of cold air hits your face. Ah, instant relief. It's something we totally take for granted, right? But behind that simple comfort is this brilliant piece of engineering. So in this explainer, we're going to pull back the dashboard and see exactly how your car pulls off this little piece of everyday magic. So, yeah, how does it do it? How can one system give you ice cold air in July and then blast you with warm air in December? It's pretty amazing when you think about it. And that's the big question we're going to tackle as we break down the mechanics, the history, and even the future of your car's climate control. All right, let's dive right in. First things first, we gotta understand the machine itself. Now, here's the secret. Your car's AC isn't really about creating cold. Nope, it's all about moving heat. Your car's AC is basically just a very, very efficient heat-moving machine. And the way it moves all that heat is with a process called the refrigeration cycle. You know, it's pretty much the exact same principle as the refrigerator in your kitchen, just built for your car. The whole thing works by taking a special fluid, a refrigerant, and forcing it to switch back and forth between being a liquid and a gas. And it's in those changes of state where all the magic happens, where heat gets absorbed and then released. Okay, so this process might sound a little complicated, but it really just boils down to 4 key steps that happen over and over in a loop. Let's walk through them. First, you got the compressor. You can think of it as the heart of the whole system. It squeezes the refrigerant gas, which makes it super hot. Then that hot gas flows up to the condenser at the very front of your car, where the outside air cools it down and turns it into a liquid. This is the moment where all the heat from inside your cabin gets dumped outside. Next, that liquid goes through an expansion valve, causing a massive pressure drop that makes it intensely cold. And finally, the super chilled liquid flows into the evaporator, which is tucked away behind your dashboard. Your car's fan blows air across it, that air gets nice and cold, and the refrigerant absorbs the heat from the cabin, turning back into a gas to start the whole cycle over again. It's just a continuous loop of grabbing heat from inside and kicking it to the curb. Now, that basic system, incredibly effective, but for a long, long time, it was completely manual. You were the one who was constantly fiddling with the knobs. So let's talk about the next big step, the automatic upgrade, where we gave this system a brain. And really, the difference is all about brawn versus brains. A manual AC is all brawn. It's a simple on-off system where you do all the work, constantly tweaking the fan speed, adjusting the temperature, but automatic climate control, that's the brains of the operation. You just set the temperature you want, let's say 72 degrees, and the system completely takes over. It is the definition of set it and forget it. So how does it think for itself? Well, it's all about data. There's a central computer, a control module that's constantly getting fed information from a whole network of sensors. You've got temperature sensors for inside and outside. There's usually a sunlight sensor right on the dashboard that measures how hard the sun is beating down. Some newer cars even have humidity sensors. The system takes all of this data and then automatically adjusts the fan speed, where the air is blowing, and the temperature mix to perfectly maintain that environment you asked for, all without you having to touch a single dial. This kind of automated comfort feels totally standard now, doesn't it? But man, it has been a long journey to get here. The history of car AC is this really cool story of how a clunky, super expensive luxury item became an everyday feature that, let's be honest, most of us can't live without. Just look at this timeline. The very first optional AC showed up way back in 1939 on a Packard, but it was a monster. It took up half the trunk and cost what would be over $6,000 today. Can you imagine? The real game changer came in 1954 when Nash came out with the all-weather I. This was the first system that had all the parts integrated up front in the engine bay, and its design basically became the blueprint for every modern system. By 1969, more than half of all new cars in the US had air conditioning. It had officially arrived. But it wasn't just the mechanics that were changing. The actual chemicals making it all work have gone through a huge transformation too. The original stuff, R12, also known as Freon, was amazing at cooling, but we later found out it was destroying the ozone layer. So the industry switched to R134A. That was safe for the ozone, but it turned out to be a pretty nasty greenhouse gas. So now today's new cars use R1234YF, which has a really low global warming potential. You can see a clear shift towards trying to make these systems more sustainable. And that brings us to right now. I mean, the basic problem of making a car's cabin cold has been solved for decades. But now, engineers are facing a whole new lineup of really complex challenges as cars themselves are leaping into the future. And the biggest challenge today, without a doubt, comes down to one word: energy. Think about it. In a gas car, the AC is a relatively small drain on the engine's power. But in an electric vehicle, it's a completely different world. The climate control can be one of the single biggest drains on the battery. And to give you an idea of just how big of a deal this is, there are new experimental systems being worked on that could extend an EV's range by as much as 70%. That one number tells you everything you need to know about how critical efficiency has become. So when you boil it all down, the key hurdles today are really threefold. First, like we just said, energy efficiency. That is number one, especially for EVs. Second is cost and complexity. I mean, all these smart controls and sensors, they're expensive to develop, expensive to build, and can be expensive to fix. And third, environmental regulations just keep getting tougher and tougher, pushing for even cleaner chemicals and more efficient designs. But you know, with every single challenge, there comes innovation. So for our last section, let's look ahead and see how these challenges are shaping a future of in-car comfort that's way smarter, a lot cleaner, and much, much more personal. This quote from an industry analysis really just says it all, doesn't it? The future isn't just automatic anymore, it's intelligent. We are moving towards systems that are driven by artificial intelligence, systems that can crunch massive amounts of data in real time to create the absolute perfect cabin environment, all while using the least amount of energy possible. So what does this AI-driven future actually look like when you're in the car? Well, we're talking about systems that use machine learning to figure out that you like it a little cooler on your morning commute, and will just anticipate that for you. Air purification is going to go way beyond just filtering dust. Future systems will actively scrub pollutants and allergens out of the air. We're going to see hyper-personalization, where every single passenger can create their own little microclimate. And with IoT integration, you'll be able to pre-cool your car from your phone, and the system will have already checked the weather to figure out the most efficient way to do it. So it all leads to this final, really fascinating question. The goal has always been comfort. But we're moving from a world where we had to manually ask for it to a future where it's just anticipated for us. So when your car's climate control can actually learn your habits, when it knows you better than you know yourself, what will that ultimate predictive comfort truly feel like? That's something to think about the next time you feel that cool breeze on a hot day.